this relation is defined on the set of natural number to natural number. The value of C when T of C is equal to 212. Whatever number you give for X, that is, you can take any number for X. That means your domain is the set of real number. So the value of X is 2. According to this definition, it is 2A plus B. Hello everyone, a warm welcome to one and all. This is Shruti lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in our previous session, we have learnt about relation and how to write the domain and range of the given relation. In our previous session, we have discussed about concepts of relation, how to write the domain and range, codomain of a given relation. So what do you mean by relation? A relation is R is always a subset of a Cartesian product A cross B. So it is said to be a subset of Cartesian product two sets A cross B. So how many relations can be formed in A cross B? Since R is a subset of Cartesian product A cross B, so number of subsets is nothing but number of relation. So if A cross B contains PQ elements, where P is the number of elements in A and Q is the number of elements in B, then number of relations can be formed is 2 to the power PQ. This is same as the number of subsets formed by a given set. Also, we have learned how to write the domain, range, codomain of a given relation. Suppose R is a relation from set A to set B where they are non-empty sets, then A is called the domain, B is called the codomain, and the image of all the elements in A inside B are called range. So, for example, if I take a relation R is equal to 1, 2, 2, 3, 3, 4, 4, 5, etc. in a set, then the first of all set first elements are called as domain and the set of all second elements are called as range. And the complete second set, when it is from A to B, the complete second set B is called the codomain of a given relation. Next, we come across a concept called function. So what do you mean by a function? A function is also a relation with certain condition. Next, we'll come across real valued function and real function. Later, we will be learning about algebra function, that is how we add, subtract, multiply or divide any two functions or two or more functions. Let us see what are functions. I said a function is a relation from a non-empty set A to a non-empty set B where every element of the domain set must have only one image in the codomain set. That is what the definition of the function. For example, let me take two sets, set A and set B. Let me take the elements of A or A, B, C, D, and here you have 1, 2, 3. The condition is that every element in the first set or the domain set must have an image in the second set, but there should be only one image. For example, A should have one image, B should have one image, C should have one image, D should have one image. But the condition is that every element should have only one image, See here, A has only one image, B has only one image, C has 2 as an image and D has 3 as an image. So this is a function. In other words, we can say that no two pairs can contain the same first element. So what are the first elements here? A, B, C, D. They are different. So when you write this in a roster form, no two first element must contain the same. That means one element cannot have two images. For example, so if I write A, B, C, D, let me write it as apple, ant, ball, cat, dog. So if I write this. Then this is an example for a relation because the word contains the first letter in the domain set. So you can see B has the image ball, C has the image cat, D has the image dog, but A has the image apple and ant. When you write this in the roster form, what happens? This is A apple, A ant, B ball, C cat, and D dog. So this is how you are going to write the relation set. But what is function? So I said no two first element must be same, but you can see here you have same element in two ordered pairs. That is, the first element in the two ordered pairs are same. So therefore this is not a function. So this is not a function. Then what do you mean by function? A function is a relation from a non-empty set A to non-empty set B, where every element in the first set must have only unique image or one and only one image in the second set. Or in other words, we can say no two pairs can contain the same first element. Next, so I said the same element cannot have two images, but more than one element can have the same image. For example, here I have taken, you can see A has the image 1, B has the image 1. Both are two different elements, but their images is same. So what is the condition here? The element cannot have two different images, but two different elements can have the same image. Next, we will see how we denote mathematically the concept of function. Here it is. If f is a function from A to B, we write all ordered pair belongs to f. What is that? That means the image of A is B. That is, f of A is equal to B, and B is one and only image for A. Next, so B is called the image of A under F, and A is called pre-image of B under F. So any function from the set A to set B is denoted like this. So this is the notation we use to denote or write a function from set A to set B. Next, we will examine or verify. Here are few examples of functions or relations are given in the roster form. So we will verify whether they are function or not, and we will justify the answer for the question. Next, R is equal to 2, 1, 3, 1, 4, 2. What is function? A function is, so a relation is said to be a function if every element in the set have unique images, only one image is in the second set. So if you write this, then you can see, if you can draw and verify through arrow diagram also. So what are the elements in the first set? That is 2, 3, 4. They are the domain elements, and second set you have only 1 and 2. So it is clearly seen that 2 has only one image, 1. Next, 3 has only one image, 1. 4 has only one image, 2. Yes, this is function. More than one element can have same image, but the same element cannot have two different images. So here you can see 2 and 3 have same image. So they are not repeating. The ordered pair here does not contain any repeating first element. So therefore we can say this is a function. Next, we have 2, 2, 2, 4, 3, 3, 4, 4. Clearly we can say, you can see the first two ordered pair, the first two elements are repeating. To be a function, the ordered pairs cannot have the same elements in the first place. So therefore, this is not a function. So how we will justify this? Because 2 has two images, 2 and 4. So for an element, you should have only one image, but here it has two images. Therefore, this is not a function. Next, we have 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. Each elements in the first ordered pair have different images. So therefore, this is an example for function. Next, we will take 2, 1, 5, 1, 8, 1, 11, 1, 14, 1, 17, 1. So if you write this in an ordered pair set, so you have 2, 5, 8, 11, 14, 17, and here in the codomain you have only single element, that is 1. So you can represent it through arrow diagram. Yes, it is a function because for 2 there is only one image 1. Similarly, for all the elements here they have only one image 1. So therefore this is a function. Next we have 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6, 14, 7. So you can see here no pair contain the same first element. That means no elements have two images. So all images are different. So therefore this is an example for function. Next, similarly you have 1, 3, 1, 5, 2, 5. Clearly from the first two ordered pair, 1 is repeating in the first place. So therefore it is not function. Next, we come across two types of function called real valued function and real function. What do you mean by real valued function? I said if f is a function from set A to set B. So set A is called domain, set B is called codomain, and the images of all the elements lies in the codomain. So they are called as range of f. Now, what do you mean by real valued function? If the range of the function is real number or any subset of real number, that it may be a natural number, integers, fractional, rational or irrational. So if the range of the function lies in the set of real number or in any subset of a real number, we call it as real valued function. Then what do you mean by real function? If both domain and range of the function is the set of real number, then we call it as a real function. That is, f is a function from set of real number to set of real number. So if the domain and range lies in the set of real number, we call it as a real function. Next we have a question. Let n be the set of all natural numbers and the relation R be defined on n such that R is the collection of all ordered pairs x, y, where y is equal to 2x, x, y belongs to n. What are the domain, codomain and range of R? Is this relation a function? So here is given, it is a set of natural number. So this relation is defined on the set of natural number to natural number and or y is equal to 2x. Let me write R in a roster form. So take the values for x. So natural numbers means it starts from 1. So substitute the values for x as 1. So if you put 1, write it an odd pair 1. Y is equal to 2x means 2 1s are 2. If you put 2, it is 4. If you put 3, it is 6. If you put 4, it is 8. And it goes on like this. Because n is infinite. The set of natural number is infinite. So therefore, your relation set is also infinite. Now, what are the domain, codomain and range of R? They have asked you. You can see here 1, 2, 3, 4. So you can take any value for x in the set of natural number. That means your domain is the set of natural number itself. So if you go on writing the ordered pair, you will get the numbers from 1, 2, 3, 4, 5, 6 till infinity. So that is nothing but your set of natural number. Then what is your codomain? Your codomain is the complete second set I said. So what is your second set? The set of natural number. Next is range. Clearly you can see here y is equal to 2x. Multiply any number, that is the answer is even number. So y is equal to 2x means you can see if you put 1 you will get 2, 2, 4, 3, 6, 4, 8. That means you are getting only even natural number. So therefore your range is even natural numbers. So this is the domain, codomain and range. One more question is given. Is this relation a function? So function, let me write it in an ordered arrow diagram. So 1, 2, 3, 4, 5, 6, 7, etc. 1, 2, 3, 4, 5, 6, 7, 8, etc. So for 1, it is 2. For 2, it is 4. For 3, it is 6. For 4, it is 8. So it goes on like this. So for every element you can pair. For 5 also you can pair, 6, 7 also you can pair. So for all the natural numbers in the first set, you have an image in the second set. That means all the elements in the first set are paired. So therefore, this is function. And one more condition is that all elements in the first set have unique images. That is their images, one and only one images. So therefore, it is a function. So therefore, what I conclude is here R is a function. One more important concept is that all relation cannot become a function, but every function is a relation. What is the definition of a function? A relation F is said to be function, we say. So therefore, to become a function, it must be a relation. Therefore, every relation cannot become function, but all functions are a relation. That is, they are the subset of Cartesian product. Next, we have a very simple question. A function is defined by f of x is equal to 2x minus y. Find the values of the following. So we have the first one, f of 0. Just replace the value of x with 0. 2 into 0 minus 5, which is minus 5. Next, f of 7. 2 into 7 minus 5. 14 minus 5, which is 9. Next, we have f of minus 3, 2 into minus 3 minus 5, minus 6 minus 5 minus 11. Question number 4. The function t which maps temperature in degree Celsius into temperature in degree Fahrenheit is defined by t of c is equal to 9c by 5 plus 32. Find the following. So the very first one is we are supposed to find t of 0. That means in the place of c, you are substituting 0. So this is 9 into 0 by 5 plus 32, which is 32. Next we have t of 28. 9 into 28 by 5 plus 32. So after solving this, you will get it as 50.4 plus 32. So this is equal to 82.4. Next we have t of minus 10. So this is 9 into minus 10 by 5 plus 32, which is, so you can get cancels here. So minus 18 plus 32. So your answer is 14. Next we are supposed to calculate the value of c when t of c is equal to 212. So fourth one, t of c is equal to 212. So what is t of c? 9c by 5 plus 32 is equal to 212. So 9c by 5 is equal to 180. So c is equal to 180 into 5 by 9. 9 ones are, 9 twos are, zeros are. So your answer is 100. So the value of c is 100. As in the case of relations, we have found the domain and range. We can find the domain and range of the functions also. Here is a question given. Find the domain and range for the following functions. So the first one is f of x is equal to minus modulus of x. So before that, what do you mean by modulus function? So modulus function, it is always denoted by mod x. What does this mod do? So the purpose of mod is, suppose you have any number, the answer is always positive. For example, for 0, it is 0. But if you have minus 3, then it will make the number positive. It will make the number positive. That is taking negative of the given number so that it will become positive. Suppose you have any number like half, 1 by 2, then your answer is 1 by 2 only. But if you have minus 3 by 7, then to make it positive, the function take negative so that it will become positive again. So that is 3 by 7. So any number inside the modulus function, the answer is always positive. But here you have negative sign outside the modulus function. So let me apply. Now take f of 0. F of 0 means minus modulus of 0, which is 0 only, because 0 is neither negative nor positive. It is always a neutral number. Suppose if I take f of minus 1, then it is minus of modulus minus 1. What is modulus of minus 1? It is 1 itself, but outside you have minus. Now let me take 2. So it is minus modulus 2. What is modulus 2? 2 itself, but outside you have minus. Similarly, you take minus 7 by 3. So it is modulus of minus 7 by 3. What does the modulus function do? It makes 7 by 3. But outside you have negatives. Whatever number you give for x, that is, you can take any number for x. That means your domain is the set of real number. You can take any values for x. But what about the range here? What is the images you are getting? They are all minus 1, minus 2, minus 7, 3. For 0, you are getting 0. But for all other values, the answer is negative. So how we will write the negative real numbers? In the form of intervals. So therefore, here range is minus infinity to 0. So for all values of x except 0, for 0 you are getting 0, so you are going to include the value of 0. For any other value, whether it may be negative or positive, the answer is always negative, because you have negative outside the modulus. The modulus function makes the value positive, but outside you have a negative sign. So therefore your answer is always a negative real number. So therefore your range is always from minus infinity, 0. Next we have f of x is equal to root of 9 minus x square. So see this x square. Whatever value you put for x, it is always positive because you are squaring the given number. If you put minus 3 also, minus 3 whole square is plus 9. So the value of x square is always positive. But what about the value when it is inside the square root? So let me check what I'll get. So let me check for f of 0. So it is root 9 minus 0, which is root 9. Next we'll check for f of 1. So it is 9 minus 1. So you will get root 8. F of minus 1 is also root 9 minus 1, which is root 8. F of 2, root 9 minus 4, root 5. F of minus 2, root 9 minus 4 again, which is root 5. Next f of 3, root 9 minus 9, which is 0. F of minus 3, root 9 minus 9, it is 0. Take f of 4, it is root 9 minus 16, which is root minus 7. But these type of numbers are not real number. A root of negative number is not possible in the set of real number. So you can take f of minus 4 also. So here also you will get 9 minus 16, which is equal to root of minus 7. But this does not belong to the set of real numbers. So therefore, the values you can give for x is only from minus 3 to plus 3. So if you see the number line, so you have 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. So you can take all the values from minus 3 to plus 3. So therefore, the domain of this function is from minus 3 to plus 3. But what about the range? So for 0, you are getting root 9. That is, the maximum value is 3. And for all, 0, root 5, root 8. So all values lies between minus 3 to plus 3. That is from 0 to 3. So therefore, the range of this function is 0, 3. Because even though you put negative number there, your answer will become positive. So therefore, the domain is minus 3 to plus 3 and the range of this function is 0, 3. Next we have Find the range of the following for the function. So here we are supposed to find only the range. First one, f of x is equal to 2 minus 3x. X belongs to R, x greater than 0. So the domain is x belongs to R and the condition is x greater than 0. That means here your x is only positive real numbers. So even though x belongs to the set of real number, the condition is x greater than 0 means you are supposed to take only the positive real number. So for the first one, let me take f of x is equal to 2 minus 3x. So let me see the value of x and f of x. Suppose I take 0. What is the value? 2. Suppose I take 1. The value is minus 1. Suppose I take 2. The value is minus 4. Suppose I take 1 by 3. The value is 1. Because 3 into 1 by 3 get cancels. 2 minus 1 is 1. Similarly, I can take, suppose I take 1 by 2. Again, you will get the answer as 1 by 2. So, if you go on taking only the positive values, because the condition here itself is given, you should take the positive real number. So, you go on taking the values. So, you go on taking the values. The maximum value you can get is 2. That is for 0. But the condition is here, you cannot take x is equal to 0. So, all the values lies less than 2. That is, you can see here 1 is less than 2, half is less than 2. And you go on increasing the value after 2, you will get only the negative real number. So, therefore, your range for this function is always less than 2. So, therefore, I will write open bracket because it is strictly less than 2. And all your answer is less than 2. That is, you will get until negative real number. So, therefore, the range of this function is minus infinity, comma 2, both open intervals. Next, we have one more function, f of x is equal to x square. X is a real number. So, we know that x square makes all real numbers positive. So, therefore, this is positive, plus 2 is also positive. And your domain is real number. So, what about the range of this function? That is also positive. But how we will write the range of this? So, if you put x is equal to 0, the maximum value is 2. And if you put x is equal to 1, it is 3. X is equal to 2, it is 6. So, it goes on like this and it starts from 2. If you put x is equal to minus 1 whole square is again plus 1. 1 plus 2 is 3. So, therefore, the minimum value you can get is at x is equal to 0. So, therefore, the range of this function starts from 2 and it moves up to infinity. As you take more values for x, you will get more values in the range. So, therefore, the range of this function is 2, infinity. Next, we have f of x where x is a real number. So, clearly you can see f of x is equal to x. That means what? If you put f of 1, it is 1. If you put f of 0.3, it is 0.3. If you put f of minus 2, it is minus 2. Whatever you take the value of x, your image will be same. So, therefore, if x is a real number is the domain for the function and the range of this is also the set of real number. Similarly, you can verify whenever the function is given, you can write the domain and the range of the given function. So, these type of question will carry 1 or 2 marks in your examination. That is to find domain and range of the given function. Next, we come across a very important concept called algebra of real function. What are the functions we are discussing? It is only real in the set of real numbers. So, therefore, we call them as a real function. So, what do you mean by this algebra of real number? Here we are going to study how we will add any two function, subtract any two function, multiply, divide, or what happens when it multiplied by a constant, that is a scalar. So, now let us study it one by them. Suppose you have two functions. F is a function from x to r and y is a function from x to r. Remember, all sets are subsets of real number. So, therefore, let f and g be any two function and x is a subset of r. It may be any set, natural number, whole number, or complete set of real number itself. Then, we define f plus g of x from x to r. That is, the sum of any two function is given by f of x plus g of x for all x belongs to x. So that is the first elements must be in the first set. Suppose I take f of x is equal to 2x and g of x is equal to 1 by x. Then how we will write f plus g of x? That is f of x plus g of x. So add it 2x plus 1 by x. So this is your f plus g x. That is sum of any two functions. Next, in the similar way, we have a subtraction of two functions. That is, if f and g are any two real function, then f minus g of x from the same set is defined as f of x minus g of x for all x belongs to x. Suppose I take f of x is equal to x square and g of x is equal to 2x. Then how can I write f of g minus x? That is f minus g of x is nothing but f of x minus g of x, which is equal to x square minus 2x. Next, I have a multiplication by a scalar. Suppose you have a function f from a set to R, then alpha is any scalar. That may be any numerical value or any constant value. Then how we will write the product of a function with alpha? That is alpha f of x is nothing but alpha into f of x. Suppose you have f as x square and 3 is any scalar. Then 3f of x is nothing but 3 into f of x. That is 3 into what is your f of x? X square, 3x square. Just multiply the scalar quantity with the given value. You will get a multiplication by a scalar. Similarly, how we will multiply two functions? So that is also called as point-wise multiplication. Suppose let me take two functions. F of x is equal to x square and g of x is equal to x plus 1. Very simple. So that is fg of x is given by f of x into g of x. Let me try what is f of x into g of x. So f of x into g of x is equal to x square into x plus 1. When you multiply, what happens? X square into x cube plus x square. So this is the product of any two functions. Next, we have quotient of any two real functions. That is, suppose f and g are any two real function defined from the same set x to r, where x is a subset of r, then f by g, that is the quotient of any two function, is given by f of x by g of x, where g of x is not equal to 0. So remember, the denominator cannot be equal to 0. You should remove the value which makes the denominator as 0. Suppose, let me take f of x is equal to x square and g of x is equal to x minus 1. So how we can write f of x by g of x? That is, f of x by g of x can be written as x square by x minus 1. But what is the condition here? G of x cannot be equal to 0. Then what is that? Is x minus 1 cannot be equal to 0. That is, x cannot be equal to 1. Why? Because if you put x is equal to 1 there, 1 minus 1 is 0. So the condition, the denominator cannot become 0, is very important while writing the quotient of any two real functions. So here we have two functions, f of x is equal to x and g of x is equal to root x. We are going to find all the sum, difference, product and quotient. Remember, these type of question carries 3 marks in your examination. That is, any 3 from this, either the sum, product, difference or quotient. So any 3 from this. Now let's see what is f plus g of x. So f plus g of x means f of x plus g of x. That is, what is f of x? X plus root x. Similarly, f minus g of x. That is f of x minus g of x. X minus root x. Next, fg of x. F of x into g of x. That is x into root x. So you can also write if this is x and this is x power 1 by 2, this is x to the power 3 by 2. The laws of indices, you can add the powers. 1 plus half is 3 by 2. Next we have f by g of x. So that is f of x by g of x. So what is the condition? G of x cannot be equal to 0. How will write this? X divided by root x. So you can see here x can be written as root x into root x. So therefore if you write this as root x into root x over root x, so get cancels, your answer is root x, and here root x cannot be equal to 0. So that means x cannot be equal to 0. Next we have one more question. F of x is equal to x square, g of x is 2x plus 1, and find all the algebraic sum, difference, product and quotient of two real functions. Let's see what is f of x plus g of x. That is f plus g of x. So that is x square plus 2x plus 1. Next, f minus g of x. So that is f of x minus g of x. What is your f of x? X square minus 2x plus 1. Remember to write in bracket when you have a binomial. So you have a binomial term, so the sign may get changed. So be careful while doing this. So this is x square minus 2x minus 1. Or directly you can write when you are subtracting, directly change the sign and write, you will get the answer. Next, fg of x. That is f of x into g of x. That is x square into 2x plus 1. So when you multiply this, you will get it as 2x cube plus x square. Next, f by g of x, which is f of x by g of x. But the condition is g of x cannot be equal to 0. So your f of x is x square by 2x plus 1. So what is the condition? 2x plus 1 cannot be equal to 0. That means 2x cannot be equal to minus 1. X cannot be equal to minus 1 by 2. So therefore here the condition is x cannot be equal to minus 1 by 2. If you substitute here x is equal to minus 1 by 2, the denominator will become 0. So therefore you should remove the value which makes the denominator 0. That's why we have to write x is not equal to minus 1 by 2. Now here is a question given there. Let f is equal to 1, 1, 2, 3, 0, minus 1, minus 1, minus 3 be a function from z to z defined by f of x is equal to ax plus b for some integers a, b. Determine the value of a and b. So whenever you have this in a roster form, you can write in the form of f of a is equal to b. So now let me write this. F of 1 is equal to 1, f of 2 is equal to 3, f of 0 is equal to minus 1, f of minus 1 is equal to minus 3. This is how we write the ordered pairs in terms of function. That is, image of 1 is 1, image of 2 is 3, image of 0 is minus 1, image of minus 1 is minus 3. Now they have given how this function is expressed. If f of x is equal to 1, according to this definition, your answer is a plus b because the value of x is 1. Now for this, so the value of x is 2. According to this definition, it is 2a plus b. Here the value of x is 0. 0 into a is 0. So the only element is b. Next we have f of minus 1. When you write minus 1, it is minus a plus b. Now you have 4 equations here. Solve these 4 equations to find a and b. Now from the third equation, if you take this as equation 1, 2, 3 and 4. So from equation 3, you have that is b is equal to minus 1. Now substitute the value of b in any one of these equations. That is 1, 2, 3. I'll take from 1. What is equation 1 you are having? 1 is equal to a plus b. So this implies 1 is equal to a minus 1 because value of b is minus 1, When this minus 1 go to your left hand side, then the value of A is 2. So this is the value of your A and B. In today's session, we have discussed what do you mean by function, what is real valued function, real function, and how to write a domain and range for a given function. Also, we have learned the algebra of real functions, how to add them, subtract them, multiply them, and divide them with the given condition. I hope you understood the concepts very well. In the next class, we will be studying about some special function with their domain, range, along with their graphs. So, which is very important, which carries 5 marks question in your examination. We'll discuss it on our next session. Until then, keep watching, keep learning, and keep exploring. Thank you.